Let's talk about our results from this worksheet that we just filled out to see how we did. Now this will help us review for today's lab, talk about the things we did yesterday, and kind of getting us into what we're going to be doing today. First question asked, how does the mass of two liquids, when made into a solution, compare to the individual masses of each liquid? Basically asking you for your results from yesterday, right? Yesterday we measured a solution with water and ethanol, and your job was to find those two masses before, make that solution, decide if the mass changed. Who can answer that question for us? Anne?
When the two liquids are combined, the mass doesn't change, however the volume.
Very good. We did notice a little bit of a volume change, didn't we? And that sometimes does happen when you mix two liquids. But we noticed that for the most part, our mass did stay the same. Now, we did notice something. A few people noticed the mass changed slightly. We talked about that yesterday. Why might your mass change slightly, even though it probably shouldn't? Joe?
Human error.
Human error. What would be a couple examples of human error that might happen in our lab? Joanne?
Using a little bit more liquid than you're supposed to.
Right. There's always that chance that we're a little bit off. Okay? Even if we're eye level and we're looking at it very closely, you could still be slightly off. Joe?
All the drops coming out of the first.
Right. Exactly. And all the drops might have came out of the graduated cylinder. Remember I told you yesterday, try to hold it there for a minute. Try to get every drop. 1 drop, 2 drops could be the difference of 0.2 of a gram, which would show a little bit of difference in your results. Today, who can remind us what our lab today is going to be about? What are we trying to find today? Deshay?
A solution by mixing salt and water.
Okay, so you're going to possibly be making a solution out of salt and water. What are we trying to find out about this solution? Luke?
Mass volume changes.
Right, if the mass and volume changes, okay? More so concerned about the mass, right? We want to decide today if when we mix salt with water to make a solution, does our mass change? Just like yesterday, we measured to see if when we add liquid to liquid, if our mass changes. Results in. And the last one asks you to conclude your results. Who can tell us what that means once again? What's it mean to conclude your results? Luke?
What did you get out of it?
Yeah, what did you get out? What did you find in that situation?
It has to be what? Yes, exactly. Very good. I don't have any ways of getting this figured out. I can ask the next sanitizer. You can get behind the desk.
I got 10 milliliters.
What was our difference in the lab? Did we get to that
So
step?
the grams were actually the same, and that one was 3 different.
3 grams different?
No, it was the same. We actually guessed the same.
You got the exact same. So was there any change?
Nope.
That's awesome. You guys did a good job with that. Once you measured the mass of your water and your salt, you made a solution, correct? And the goal was to basically, I kind of told you this, but I don't want to give it away too much, but to find that individual mass of salt, individual mass of water, right? Add those two together for your prediction and see how close you came with your final answer or difference, so to say. Can I get our differences from each group? Let's compare our differences amongst groups. Good. So you're noticing that we did not get any totals above 2 grams in this situation. I really like these first couple numbers here. But if we look at these results and kind of see where we stand in this, what can we conclude on this lab today? What happens to the mass? Luke?
It stays the same.
Who agrees with Luke that even though we see a little bit of a difference in some of these, it does stay the same? And once again, who can remind us why we might not see perfect numbers in a lab like this? Mikhail?
Human error.
Human error.